Good afternoon, viewers, investors, partners, and everyone in the LLC Sovelmash project. You're watching Expert Time. We'll discuss the latest project news and answer your questions.
Good afternoon, dear investors. Good afternoon, dear partners. Good afternoon, esteemed viewers. Right away, to anticipate all your important questions and provide clarity, I'll say this. We have successfully received the very latest and most up-to-date data for the upload. We officially received the complete upload number on Monday. It's important to note that 2 parts had already been fully approved, and there were only minor comments on just one specific part. Today, an important meeting is currently taking place where all of the ongoing projects are being thoroughly reviewed, including comprehensive information about the positive results of the recent Commission's crucial meeting. I don't have all the information yet, so I think it would be right not to harbor any false hopes or assume that we'll be in for some kind of surprise. The likelihood that the project will be approved today is close to zero. We have been eagerly waiting for this moment, which has now truly arrived, when we can finally begin the crucial testing of these powerful engines that have been manufactured industrially and with precision. Stamping, casting, winding, and everything else. Accordingly, at different supply frequencies and at different voltages. And then all this data will be published, posted on the LLC Sovelmash website and offered for sale. However, these advanced motors will not exclusively be offered for open public sale. Negotiations are also currently underway to supply these specific motors, certain specialized models, for their integral use as a crucial part of various equipment systems. Our objective is clear: to make money for our investors. To do this, we need to produce products. In the previous webinar, I mentioned that the main cost items in production are determined by the cost of materials. That's precisely why it is most profitable to produce material-intensive products. And in very large quantities, and those that operate at sufficiently high frequencies to effectively maintain competition. For example, this particular system works at 50-75 hertz. Beyond that point, there are significant losses in the iron, and the motor ultimately burns out. This operates at 600 hertz. But 1.5 kilowatts and 1.5 kilowatts for these and those. These motors can be sold a bit cheaper than the 1.5 kilowatt ones and still make good money. That's why this project is aimed at making money by selling products that use patented solutions based on our technology. And I'd like to point out this motor is not from an angle grinder. There are 30 laminations in those. I mentioned 1.75 kilowatts. But here there are 40 laminations, which corresponds to more than 2.2 kilowatts. The availability of mass production technologies allowed us to radically change the motor's design. It wasn't the principle that was changed, but specifically the structural elements. We took a risk, and it paid off.
Will this small rotor shaft withstand a load of 1.5 kilowatts?
It will, because power is the product of RPM and torque, divided by 9,550. Accordingly, the torque on this motor at, say, 3,000 RPM and at 18,000 is the same. But such motors are always used with a gearbox. Interestingly, we're now talking about a small truck that drives around courtyards. Since it has a load capacity of 1.5 tons, we're talking about the drive system. We're saying that with this kind of drive, but only with 70 battery packs. That's over 4 kilowatts. But we know that all electric machines have very poor performance at low speeds. The lower the speed in the air gap, the worse the engine efficiency. However, if the motor operates starting from 3,000 revolutions per minute and above, the efficiency is very high.
So a gearbox is added to the system.
And it's still there. The gearbox will still be there, regardless of the motor. Only the gear ratio will be different. At the same time, it would be easier for drivers to control the speed. And on top of that, it's less weight, lower cost, and everything else. It's easy for a linear motor to resist if something gets jammed. However, when the mechanism is securely closed, ensuring it remains in that position so it doesn't inadvertently open is not particularly difficult. Overall, a linear actuator is significantly cheaper and operates much more smoothly and efficiently, and the overall noise level is significantly lower. Therefore, in my considered opinion, the linear actuator is perfectly suitable for its intended use as a reliable drive mechanism in both doors and elevators. Moreover, doors can vary, so a linear motor based on a single plate can be assembled in different lengths depending on the width of the door. Although it's not strictly necessary to do this at all. Break time, 0.3. Why is that? Because the motor will be securely mounted on the cabin itself, and there will only be a simple metal plate on the door. Absolutely nothing else will be present. Thank you very much.
What kind of engine do you think is necessary for an electric car of the family, urban and country type, and what kind of transmission scheme is needed for such a vehicle?
To be honest, colleagues, I haven't done the calculations at this point. Transport is one thing, but the main issue is industrial consumption. That's where the main load is, because it needs to be replaced with something newer. For example, a pump based on one type of motor or another is a completely different matter in terms of cost. In both of these specific cases, you will definitely need a frequency converter, but the overall dimensions and the physical size of the pump impeller are quite different. And accordingly, so is the overall price, especially when considering its application for various utilities and public services and other essential infrastructure. That's why there are companies in Russia that produce good pumps. There are also manufacturers of frequency converters in Russia that operate up to 900 hertz and are for general industrial use. Please go ahead and assemble them. In some specific cases, an encoder is indeed needed, but certainly not to such an extensive extent. Let's put it that way. Besides, we sincerely hope to discuss our very own advanced frequency converter in the near future, quite soon. We're talking now about the fact that there is an opportunity on the market to control this motor. Why not? Yes, it can be enclosed in a housing, but in that case, the housing needs to be designed so that the frequency converter is built in right from the start. This will significantly simplify and reduce the cost of wiring. So if we work well with our partners, we can really surprise the world, to seriously surprise the world, especially considering that we are negotiating the first deliveries of engines, in particular for the Motilec and others, but unfortunately not with Russia. Unfortunately not with Russia.